Let's look at OpenStax College Physics, Chapter 19, Problem 61. Find the total capacitance of the combination of capacitors shown in the figure. So here we have capacitors, and I actually labeled these as C1, C2, C3, 4, 5, and 6. And we have to find the equivalent capacitance. So how do we figure out how these capacitors are connected? So I'm going to just start from here. Let's say that this is connected to some battery and there is current coming through there. So since there is current coming through here and then it splits into all of these branches, that means that there will be some sort of parallel combination here. So I'm going to follow this branch, and I see that there is a capacitor C2 followed by C1. There is no branch in between. There is no split branch in between. So there is one current that flows through this branch, which means that these two capacitors, C1 and C2, are connected in series. So then I notice also that the end of C2 and this end of C3 is connected to this end of C1 and this end of C3. So what that tells me is that these capacitors that are connected in series with one another are connected in parallel with C3. Then if I continue on this branch, I see that this one splits up. So another split means another parallel combination. So my capacitors C5 and C6 are connected in parallel with one another. C5 and C4 are not in series because there is a junction here. So the current comes through, splits up into this branch, splits up into the other branch, and these two will recombine to form a current going through here. So these two guys are connected in parallel, and the two are connected in series with C4. So let's take this in a more organized fashion. So the first thing I'm going to do is I'll say, well, these two capacitors are connected in series with one another. So C1 and C2 are in series, which means that 1 over C12 is 1 over C1 plus 1 over C2, or C12 is C1, C2 divided by C1 plus C2. I just solved the previous equation. And C1 is 5 microfarads. I'm going to skip the units. I know that the answer is going to be in microfarads. C2 is 3.5 microfarads divided by the sum of them. 5 plus 3.5 is 8.5. So this will be 2.06 microfarads. So now I have this capacitor C12 connected to the rest of the circuit, and I'm just going to leave it at this. I'll complete things as I go along. All right, so then the next thing I can do is connect these two capacitors in parallel. So I can say that C5 and C6 are in parallel. In parallel, capacitors just add, so I have C5 plus C6 is C5/6, and that will be equal to 0.75 plus 15, so that is 15.75 microfarads. So those are somewhere here. So this is my C5/6. Then I can complete the rest of the circuit. So I know that here I have capacitor 3, and I know that here I have capacitor 4. So now I notice that these two capacitors are connected in series with one another. So I will say C4 and C5/6 are connected in series. So then 1 over C4/5/6 is 1 over C4 plus 1 over C5/6. C456, which means that C456 is C4 times C56 divided by C4 plus C56. So C4 is 1.5. C56 we just calculated was 15.75 divided by 17.25. So C456 is 1.37 microfarads. So I can redraw this. I have C456 here. I have C3 there and C12. And these three capacitors are connected in parallel. So the equivalent capacitance is C12 plus C3 plus C456. C12 is 2.06, C3 is 8, and C456 is 1.37. So the equivalent capacitance is 11.4 microfarads.